My name is Maria Stone, and I study physics at San Jose State University, and I want to show you the tools, my paper tools I use in getting the magnetic field lines for different currents. So let's say I have a straight wire, and the current goes up or down, or sideways, to the left or to the right, and basically what I do is I cut a strip of paper and I put an arrow on the top, and the arrow indicates the direction of the current. So it's very easy. Let's say the current is this way. I point my thumb in the direction of the current, and I bend my fingers with the right hand rule and get the direction of the current. Get the direction of the magnetic field, sorry. So it gets a little complicated with my paper tool if your current goes in a loop. But let's say this green circle is the loop, and it goes, around clockwise or counterclockwise. So I have a paper loop in green color, and it represents the current loop, the wire, the loop current, the current loop. And the orange circles represent my magnetic fields, my magnetic field lines. So I have them on each side, and you can see that they are symmetrical because the circle is symmetrical. And in the middle I have this straight line, and that represents the z-axis, which is perpendicular to the axis of the loop. And now to get the direction of the magnetic field, again you use the right hand rule, but I use this orange arrow, and the orange arrow helps me to determine the magnetic field. So I have this hooks here that attach my magnetic field lines, and I put the arrow here at the 0, and it touches there. That means my magnetic field points up, right? And then as it travels along the magnetic line, I can see how at each point along the z-axis my magnetic field line direction changes. So it goes up, increasing angle, and then goes around. There you go.